point, Robert, if you can please go ahead and tell us your story and what is your background and professional experience.
Yeah, sure thing. Thanks, Ronnie, for that introduction. My name is Robert Alvarez. I'm head of data science for Podium Education. So my background basically is in applied mathematics. I have a PhD in applied mathematics from Arizona State University, where I worked on mathematical models of cancer. So I basically wrote mathematical models to determine how cancer would grow. And then after Arizona State, I actually begun working at Intel Corporation in a unique program they called the Rotation Engineering Program. That program allowed me to work in 3 different roles, each one being 6 months long, until I found permanent placement within a specific business group. So my headcount was really paid for by HR, and then I got to work on really cool projects. My first one was under one of the senior fellows at Intel doing clustering algorithms for the data center. So how can we use clustering algorithms to determine market fit and whether or not there were an abundance of products that really were basically doing essentially the same thing, so that we can have less products on the market to then increase, obviously, margin, since we can produce them at higher levels. My second role at Intel was under the strategy office for the Internet of Things group. In there, I was actually working in a business role. I decided to do something different that wasn't technical. And I worked in the strategy office, got to travel to China, meet with the VP of Internet of Things group. I'm still used to using Intel vernacular. So the Internet of Things group in China, and ultimately, actually, I was able to present a smart cities strategy to the CEO, or the then CEO of Intel, Brian Krzanich. My last rotation at Intel was working under the chief economist at Intel, where we were trying to come up with sentiment analysis models. So how can we use Twitter feeds and Twitter sentiment around a new Microsoft product launch to determine whether that was going to be more successful or less successful than it had been in the past, because there had been some cyclical patterns to some of the Windows launches. So like in particular, this was Windows 10. So I got to do a lot of that work, and that was super cool. Especially working with marketing data and working under the chief economist. My last position at Intel, which was the one that I did for an entire year, so that was where I found permanent placement, was in supply chain. So I used my skills of data science to optimize supply chain and operational building. So we worked on this project called, well, a typical supply chain project, which is whether we make something or do we buy it, right? So make or buy. And ran a whole bunch of simulations and determined the constraints for which it would make sense to buy and when it would make sense to build it ourselves. That got me an Intel sort of division recognition award. And then another one, I got a second reward for division recognition award for supply chain analysis for particularly for hubs in China and how we can optimize those. After leaving Intel, I actually worked for a small startup, well, relatively small, called Tamer, T-A-M-R, that is based out of Boston. The CTO is a Turing Award winner, and what they did was come up with a machine learning algorithm to tie databases together. So a typical problem in database management, especially for large corporations, and an example of this would be like Macy's, right? So Macy's owns Bloomingdale's as well as Macy's, and you might actually be in those databases in several different ways. So for example, my legal name is Roberto, but I actually go by Robert. So in one database for Macy's, I can be under Roberto, and another one I can be under Robert. But when I signed up for Bloomingdale's, I may have put in my old address in Miami, Florida, versus the Macy's one has my current address in San Francisco. But how can we use fuzzy matching and doing this at scale to make sure that we're getting a holistic view of all of your customers or your products, et cetera? And that was a lot of fun. I got to travel quite a bit as well. After leaving Tamer, I went to Metis, which is a data science boot camp here in San Francisco, and they have several campuses as well in New York, Chicago, and Seattle, where I was a senior data scientist and instructor of data science. Did that job for a year, absolutely loved it, and then I got reached out by Podium Education since they were looking for a head of data science, and that's where I've been for the past quarter and been building out courses as well as out models to improve educational outcomes for students who take our courses in universities. That's me in a nutshell.
Thank you, Robert. That's really a good intro. So just, I guess, to remind anyone that's on the YouTube live to feel free and not be shy to enter any, to put in any question on YouTube. But I'll get started with one question for you, Robert, if you don't mind.
Sure.
So for those that are not familiar with data science, because it's pretty new, it's a pretty new field, and I guess if you can tell us what is data science and why is it so much in demand these days?
Yeah, happy to. So to me, data science is really the ability to take large amounts of data and use simpler algorithms that have a probabilistic foundation to get better results at speed that you could not do if you did what we call a tops-down approach. So a tops-down approach, and this is what programming had been throughout the 70s all the way into the early 2000s, of if we wanted to capture something, we actually had to write the explicit rules to capture that. So, you know, going back to that example of trying to do fuzzy matching on my name, you would say, well, if the name is Robert or if the name is Roberto, and they're in the same exact city, right? So if the name matches or the city matches, and then try to find all these nuanced ways to try to capture everyone, that works well when you have, you know, 10,000 rows of data, right? So you have 10,000 entries in your database, but when you have 1 million, when you have 2 million or even more, right? If you're some places have billions of rows of data, that becomes much more harder, and these programs basically become impossible to manage. So data science has allowed us to use algorithms with a probabilistic foundation to do this faster and more efficiently in a way that requires less overhead. And this has, to me, has been one of the reasons why data science is so prolific nowadays and why everyone's trying to get in this field. Because we're basically doing something that hadn't been done before, right? We really are on the frontier of you know, the new technology revolution, and particularly when it comes to programming and handling data.
Okay, that makes sense, Roberto. I think we have one question here from Erin. What does a data scientist do on a daily basis?
So a data scientist actually is described as wearing many hats, right? So you usually have to communicate with stakeholders, right, to determine what it is that actually that the business needs, right? And we'll get into that more later. But you have to communicate what it is that you're trying to do with your models. There's a lot, and I mean a lot, of data wrangling. So experience or proficiency in SQL databases, Python or R programming would be essential because data is not clean, right? Maybe if you're a brand new company and you're trying to streamline things, but if you work for large companies or in particularly older companies, they have databases in many different places, and it becomes really difficult to join these databases, to filter it out exactly what it is that you need. You need a lot of, you know, some regular expressions to get nuanced information out, to build into your models. I would say a good percentage of that of your time is actually spent on data wrangling, because the models themselves, as I mentioned earlier, are fairly easy to run. It's just making sure that the data is in the right manner to make sure that these models run efficiently and get that level of proficiency or performance that you're looking to get out. So I would say a lot of it is data wrangling, followed by actual coding and like determining which algorithm is that you're going to use, trying to do a lot of data analysis and visualization to figure out, you know, what it is that's in this data so that we can extract that signal out for the model. Then a smaller percentage of that time is spent actually on running models and tuning models, and ultimately finally communicating those results to or putting that program in development or that project in development through your data engineering team.
Okay. Okay. Thank you for that. We have another question here from Steve. Um, how does data science differ from data analytics?
So I would say that data science is bigger. So if you look at a Venn diagram, right, you would say that data science is the bigger circle and data analytics is somewhere encompassed inside, meaning that a lot of the skills that you would use as a data analyst are also going to be essential for a data scientist. So things like visualization, querying data, coming up with like robust hypothesis to test, and like looking really like going really deep into the data, especially if you have subject matter expertise in that industry, right? So that's another part of a data scientist, is that sometimes in certain industries that subject matter expertise is way better than hiring a general data scientist. Um, so to me, the data analyst does a lot of that dirty work or a lot of that heavy lifting that a data scientist would do. So managing the data, querying data, extracting information out, gathering insights, and then communicating those insights to potentially a data science team so that they can then build out the models. Sometimes the data analyst can build some smaller models, and as we get to more and more low-code solutions, so things like Data Robot, Google's AutoML, or even Apple's Turing Create, I see the role of data scientists and data analysts as becoming much more nebulous than they are now. I think right now there's a bigger definition. I think we have a clearer view, but as there are more low-code solutions, you know, this allows data scientists and data analysts to become much more synonymous in the future than they are now. A good example of that would be, you know, back in the 1990s, if you wanted to build a web page, you needed to hire a webmaster. Right now, I can go to, what is it, Squarespace or Wix, and in 5 minutes, I've got a website up, right? So it won't be that drastic. And, you know, I'm not saying that in a few years, all data analysts and data scientists are going to be basically the same thing, but there are going to be more and more low code solutions for you to just say, here's my data. I've got the subject matter expertise. Let this software run the machine learning models for me and improve that performance in a way that is robust and with sound decisions.
Okay. Thank you for that answer, Robert. Let's see. I think we have probably a few folks, and there's I guess at least one. Pradeep here is asking about. I guess he's exploring career to start a career in data science. So he was wondering what would be the best way, how to make a career transition to data science.
So that is an excellent question, Pradeep. To me, to make a career transition into data science, it is not as difficult as some people would make it out to be. Most importantly, I would say by hands down, the most important skill or the most important thing that you need to have is the drive and initiative to just do the work, because you will stumble, you will fall, and that ability to get back up and try a third, fifth, 100th time is vital to success, not just in data science, but in any career. The things that you will need are going to be rolling around some programming language, typically, so scripting language. So we're talking about R or Python are the most common ones. You will need to know how to query databases. That is typically done through SQL, and have, I would say, freshman to maybe sophomore level, depending on what country you're from, sophomore level understanding of calculus, probability, and statistics to get your, that would give you a good foundation. You can go deeper, but if you want to get your foot in the door, I would say that is a great way to start. And I think How Counselor has some great counselors there to provide some of those skills for you and get you the tools you might need.
Thank you, Robert. So a follow-up question along those, I guess along those lines. So, what kind of data scientist then resume would stand out to recruiters?
That's a wonderful question. So data science resume that would stand out to recruiters is one that is more focused on things that you have done. Now, you might ask, well, I don't have a job in data science. How can I get the resume to look like it's experiential? And I would say that that's not necessarily true because of places like Kaggle where you can do competitions and other places. Just taking a data set and trying to come up with some information, having and putting about that and blogging about it. I would say that if you don't have data science experience and you're trying to get your first entry level role in data science, a phenomenal place to start would be to do that. Would be to take a data set off of Kaggle, do some in cool insights or gather some cool insights or do some nice visualizations, blog about it, tell people what you've done and post it on LinkedIn, post it on Medium, and then reference those exact same projects in your resume so that when they're looking at your resume, they're seeing it from a, hey, this person has done this before, instead of saying, can this person do this based just off of their education or prior work experience that may not necessarily be relevant to data science. Especially since we're in a tight labor market, recruiters are just looking for people who can do the job, and this is a phenomenal way to get your foot in the door.
Thank you, Robert. So another question, I think along those lines, Mark. So he's wondering what are the 3 key skills that he would need to be successful in a data scientist role?
Yeah, the 3 key skills, Mark. You need to, and I can't stress this enough, like you need to be able to communicate. So what is important to your team? What is important for the business? So you will typically get a lot of nebulous questions or high level questions of like, hey, where should we be spending our money for marketing? And that's the question that a VP or a senior manager or a director, et cetera, would actually ask the company, or so would ask the data science team. And if you say, okay, where should we be spending our marketing money? That is a question that is heavy, very vague. How are you going to be? You need to be able to then drill down to specifically what is the actual need, and it has to be phrased in a way that the data science team should be able to handle it. Sometimes that phrasing should be translated through the data science manager, but communication is a key skill. The second one would be programming. Obviously, you need to be able to script. Obviously, be able to get data, write program codes, write in either SQL, Python, R to build your models. And then ultimately, the last one is a foundation in mathematics and statistics. But and I can't stress this enough. It doesn't have to be. You don't have to have a bachelor's. You can just have a course or 2 in calculus and probability and statistics. And it doesn't have to be truly fundamental, but it helps you understanding what's going on and how to tweak the models and tune the models.
So follow-up questions, I guess, as far as programming languages, so as a technical skill that Mark would need to succeed. Is there like so for someone who doesn't know, who doesn't have any programming language experience, is there like a language that's more common than the other? So R, so you mentioned R versus Python. Which one, so if he had to pick one, which one would you recommend that he start with? And if you could also tell us what is the difference, I guess, between the 2.
Yeah, so actually I would sort of flip the question on its head a little bit. I would say, let me tell you the differences between them, and then you can decide which one's the one that should be best for you. Python is actually a very general programming language, meaning that you can do a lot of things with it, whether it's writing scientific code, whether it's using it for web pages or unit testing, etc. And it was meant to build it to be a general programming language. So there's a lot of things that you can do in Python that you cannot or is very difficult to do in R. That said, R was predominantly R actually originally comes from this programming language called S+, that was written for statisticians, right, by statisticians. So it has a lot of robust statistical measures and libraries built in. And that was really the paradigm. So you can do robust analysis in R much simpler, I wouldn't say much simpler, simpler than you can do in Python. And data science models, I then would argue that would be a little bit easier to do in Python because of the sklearn package or the library that it basically has one large repository for a lot of the machine learning models. Versus in R, those machine learning packages and libraries sometimes have to be piecemealed together. So you have to go from, you know, if you want to use logistic regression, you go to one place. If you want to use random forest, you need to go to another library. And it becomes a little bit difficult to maneuver at first, but you get the hang of it and it becomes straightforward. Now, if you're a standalone data science team that is just basically querying models and doing the analysis and whatnot, either one of these will work well. But if you're in a situation where you actually need to start implementing that your data science team is also partially data engineering and you need to start putting these codes, your software or your models into development, then I would recommend Python. R is catching up, but it's still, Python is still the clear winner.
Okay, thank you, Robert. That makes a lot of sense. Let's see, question here from Sandeep. As far as the interview for data scientist role goes, he was wondering what were the most commonly asked interview questions?
Yeah, so most commonly asked interview questions is a little nebulous, right? Because it depends on the industry that you're applying to, right? So a question at Google may be very different than a question at, let's say, Intel, right? Or a Honeywell or an IBM. But I will tell you a lot of the processes and some of the general themes that they hit on. So the process is typically a phone screen, usually with someone in HR or recruiting. It's very much like, to put it bluntly, it's do you have a pulse, right? Can you communicate what you've done? Or you sound friendly, and, you know, can they hear you smile over the phone when you're talking about the work that you've done before? Do you sound excited? Then typically after that, it's a phone screen with someone technical where they're gonna ask you to, in certain cases, it's just like solve simple probability questions, or even sometimes share your screen and write basic code. You don't have to expect it to compile. Like, you just have to be able to basically pseudocode it, unless they're specifically asking you, like, it has to compile, right? Or it has to execute. But those are few and far between. Most of the time they'll let you get away with pseudocode and say, yeah, this actually works. And because they're not actually going to hand you the data, they're just going to say, like, there's this data set called data, right? Can you extract this information out? In certain cases, you would have a second technical screen, which would then maybe dive deeper into either the probability and statistics, or the coding, or sometimes sort of the knowledge of machine learning. Then you would get passed on to, like, if you pass those, you then go on site typically and do usually somewhere between 3 to 6 interviews, because they just basically say, we're going to interview you through different teams and get different perspectives from everyone on would they like to work with you, right? Are you the right fit for the company? And in some places, I know that I've gotten the job, but did not take it because I did not like the culture. So it is actually important to pay attention to that. Those 6 interviews are going to be very different. You're going to have, someone's going to be asking you a lot of questions about your either math or machine learning knowledge, right? Knowledge of basic algorithms. Please don't think that this is going to go super deep into the weeds of, like, the latest and greatest of AI technique. It's just going to be focused on what I would call classical machine learning methods, which would be logistic regression, random forest, support vector machines, maybe some convolutional neural nets if they use a lot of that in their role, and sometimes like some linear regression. It's just high level, right? Can we peel back the layers of the onion and determine whether you've got the right needs to start the job now, and anything else can be taught at the company and can be taught while on the job. In rare instances, you will have a second onsite, but usually if you pass the first onsite, that's usually when you get to the point where you're getting an offer. And so then to make sure that I answer the question, Sandeep, it's usually around, so you should know some math, and you should, like, study up on probability and statistics questions. I'm happy to provide some references after this is over to Ronnie so that he can send it out. Probability and knowledge of machine learning, and ultimately some like cultural fit questions and like high level business questions of like, how would you tackle this problem? Or, you know, tell us about a time that you found challenging in a previous role and how did you overcome it? So those sort of high level business questions as well, and personality questions.
Great. That's a really great answer for Sandeep. Thank you, Robert. A question from Shireen, this time that's more related to your, I guess, daily responsibilities as a data scientist. So she was wondering what are the most typical, or some of the challenges you often face in your job as a data scientist. Well, what is the most common challenge and most common issues that you run into?
Yeah, so that's a great question. So to me, the most difficult challenge that I have is convincing management to rephrase their problem in a way that a data science team can handle it. And usually what happens is that they just think machine learning is magic, right? And it's hard to then say, let's take this business question and then have the data science team come up with an answer that answer didn't necessarily satisfy what it was that management wanted. So for my role, I actually have to do a lot of translation between management and sort of the technical data science team to make sure that we're building the right model based on what the CEO wants or what the VP of a specific division might want. So that's, I would say, my biggest challenge. And then the second biggest challenge, which is almost on par, is data quality. When we have data coming from many different sources, sometimes it's structured, sometimes it's unstructured, it becomes really difficult to get a flow. And as I mentioned earlier, you know, we spend a lot of time actually wrangling through the data, trying to extract sort of a signal, so to speak, and do feature engineering, because there are certain things that we capture in the data that we then have to augment or create to then get additional signal out of the model to improve performance. So there's a lot of data wrangling. And those, I think, are my two biggest daily challenges.
Okay, thank you, Robert. Question here from Bob. What advice do you have for aspiring candidates to be successful in their first data scientist career? So for freshers, someone who's starting in data scientist, what would be the biggest, I would say, advice you can give them to be successful?
Yeah, sure thing, Bob. To me, one of the most things that you could one of the most important, well, I'll give you a few different traits and you can choose whichever one that I think most resonates with you. Some of the traits that I think are important are being humble. No one wants to work with a data scientist who's kind of a jerk or thinks they're a know-it-all. Be willing to learn, right? And we see this a lot when we interview candidates, is that we tell them like, hey, how would you solve this problem? They then come back with the traditional approach, and then I say, well, we can't do it that way. And then they get defensive, or they start saying, well, that's silly, like that's the way it's done. Instead of using that as a learning opportunity and trying to figure out why the company can't use that method. Is it something deeper in either the data or the operational needs, or just because of the industry in which they're in? So be humble, be willing to learn, and be always willing to ask questions about what it is that is really driving the business needs, instead of trying to be a know-it-all and be helpful. Another thing that would be very important is so obviously the ability to sort of get back up after things have gone wrong. It's okay to fail, as long as you learn from those failings. And let's see, ultimately, and then obviously having, like, once you get your foot in the door, right? Like if you've gotten that first job, you've already got the math, the sort of math about probability and statistics down. You've got some of the programming down. You've got some knowledge of machine learning. The rest are just going to be on your own personal drive. Like, what is it that interests you? What gives, what makes you hungry to to do more? Is it being in the education space, which for me is where I've actually found my drive and where I think I found my calling? Be willing, have an open mind. And I think that's one of the most successful, one of the best tips that I can give you, Bob, to be successful in your first role.
Great, thank you, Robert. Question from Greg. So as far as career path, and I guess you know, when someone starts as a data scientist, obviously there is a progression, you know, in terms of career. There are different levels, different seniorities. So can you tell us essentially what are the main, I would say, different stages and options that someone who starts as a data scientist, what option does he have?
Yeah, so I'm assuming the majority of the listeners are aspiring data scientists or junior data scientists, and that's really the first level, right? So you become a junior data scientist. Sometimes, like I mentioned earlier in this session, that there is a lot of gray area between data analyst and data scientist. So in those specific areas, you might get your first role as a data analyst, but you actually might be doing some minor data science work. That's typical first role. Most importantly, I would say in that first role, find a mentor. Find someone who can coach you, that knows what your strengths are and, you know, helps you with some of your weaker points, but really makes those strengths shine. For then you usually get, the next role is either typically data scientist or senior data scientist. That role will typically last somewhere between 4 to 5 years, depending on the organization. Smaller organizations like startups or smaller firms are going to be quicker to progress up that ladder. In larger companies like Intel or Google or Facebook, like you can be a data scientist for a while before you get promoted to senior data scientist or head of data or like data science manager. Senior data scientists usually have a lot more oversight. They actually have a team typically working under them, where they'd be building out models in the specific area that they're in. And then this is all led then by the data science manager. So the data science manager then controls the senior data scientist, or sort of oversees the senior data scientists, who then oversee the junior or data scientists. And then ultimately you have the head of data science or the VP of analytics. Those two titles get a little confounded depending on the organization. So VP of analytics or head of data science are typically dire. And those sort of leadership roles can be found earlier in your career, depending on how hungry you are, and especially if you've got a passion for that industry. These tend to work out. But if you want to become like head of data science or director of data science for one of these large companies, you'd be I'd be assuming somewhere between 10 to 15 years before that actually happens. But in those 10 to 15 years, you can learn so much and do so much more that ultimately you decide to maybe pivot your career and do something else, or perhaps go into consulting as well. So there's so many things that you can do in data science nowadays. It's phenomenal.
Okay, great. Thank you, Robert. Another question from Tom, who's wondering, what do you like the most about your job as a data scientist, and what you don't like as much?
Sure thing, Tom. So let me first answer the second question, is what I like the most about data science, and then I'll tell you more about my roles and like what I like and not like. One of the things that I really enjoy about data science is that we're able to do things that mathematics hadn't typically done, or engineering hadn't typically done in a very long time. So what I love about the revolution of data science is we're now able to write algorithms to classify things. So if you think back in the day of like what some mathematical models did, is it just output a number. I know now, like, so think of like a regression, like housing prices, et cetera. Like that's what a lot of mathematical models were done like over 100 years ago. Throughout the last 30 to 40 years, there's been a lot of emphasis on what we call classification algorithms. And I thought that was really fruitful, of being able to put in data into an algorithm and have it predict whether it was fraud or not fraud, or hot dog or not hot dog, or you know, whether someone should get approved for a loan or denied for a loan. And I think that really has opened up the door to many things. And now we've got obviously AI and deep learning, which can do things like image recognition or come up with new videos or generate new scenes, etc. So I think we really are on a cool frontier. And that's what I love about it, the fact that we're just really the Wild West. And so many things are happening that are just fascinating. What I like about my job in particular is number one, I love to work with in the education space. So at Podium Education, we build data analytics courses, or we create data analytics courses to partner with universities. So students are actually taking courses that I've written and I've worked on, and then I build models on top of those to improve educational outcomes. So in one specific example, if a student we notice that they're actually watching the same video like more than once, or in the quiz section getting specific elements of the quiz incorrect, I can then build out models to then recommend a supplemental video that they can watch to improve that score and get them interested in it. And I think that's just fascinating, to be able to use machine learning to improve education.
That's great. That's really great. Another question, I think this time more related to, I guess, education and what training someone, I guess, can take. So boot camp or master program. So which ones, for someone who has the option between the two, which one would you recommend? Boot camp or master's program?
Yeah, so and I think this really ties down to, for lack of a better word, not prestige, but brand recognition. Boot camps and certain, I can't speak for all master's programs, but certain master's programs and boot camps actually teach very similar information. So right now, actually I forgot to include this in my bio. I'm a professor of machine learning, an adjunct professor of machine learning at Santa Clara University. The material that I teach in my Intro to Machine Learning course is nowhere near as much as the material that you would learn in a boot camp, right? And if you take the entire master's program, you then obviously get a few other skills itself, but the boot camp really just says, hey, do you have some background in programming and mathematics? Let's teach you these skills. You know, if you have a deep learning sort of, not a background, but like if you're familiar with the deep learning space, there's something called transfer learning, where you take an existing model that has been trained for something and you give it new data and you just tweak the last little layer so that it can do this new prediction, right? So think of it as like, oh, I've been training on images, but I'm going to give it new images and classify that instead. That's what boot camps do. Boot camps take a student who has a good training knowledge and then just basically tweak that very last layer of their knowledge to be able to specifically apply it to data science. They're phenomenally successful. I have seen students do some really cool projects at my time at Metis and through other places as well, like Insight Data Science and Galvanize. And the good thing about that is that it's a quicker program, right? You're usually done in 3 months, but some jobs don't actually don't know about the boot camp space, so they go, wait, what, you did a 3-month boot camp? Like, is this tied to like a university, et cetera? Their recruiters are very used to like working with universities or recognizing university names. It's less so that they understand or have a good knowledge of boot camps. Now, that said, you know, if you want a master's, you actually get a degree from a university, which is very different than a boot camp. A boot camp gives you a certificate, right? It's not worth, well, sorry, I don't want to say it's not worth anything. It does not hold the same weight as a master's degree from a university. But a master's degree at university can take you between 1 to 2 years. Although you do get some financial aid funding through the university. And in some instances, like if you're a person who needs visa sponsorship, sometimes the master's is the way to go because boot camps usually do not sponsor visas. Anything else there you'd need me to clarify?
No, let's see. No, it doesn't look like here. we'll wait, I guess, if he has a follow-up
Yeah,
question
yeah,
there.
yeah. It's just a really big open space, right? And there's so much
Um,
to do. And then no, so I'd like to add a little bit more now that I remembered something is uh, there's a difference though between doing a PhD, right? So if you're saying, hey, I want to do a PhD in data science, that is the level, what you can learn in a PhD setting is very different than you can learn in a master's or a boot camp, right? It is a very different level. And if that's the process, then yes, universities are the only way to go if you really think that you want to get a PhD in this. But if you just want to level up, so to speak, and get a job in data science and work in industry settings instead of more of like a research setting, then boot camps or masters would both serve you well, and listen to what I said earlier and determine which one is the one that's right for you.
Okay, thank you, Robert. We have a follow-up question here from Greg. So he's asking, so if you have any recommendation as far as any resources that you use to keep yourself up to date on the most recent advances and technologies around data science, because I'm sure that it changes every day.
Oh yeah, there's new stuff coming out.
So, and I'm sure that sometimes it's probably really hard to keep up. So he was wondering if there was any, what you're doing personally, and what would you recommend for someone to really stay on top of the trends and the changes in the technology.
Yeah, Greg, one thing I would recommend is Twitter. I know it sounds a little odd, but there's so many people that you can follow on Twitter. Jeremy Howard, for example, is one that I would highly recommend you follow on Twitter, who is the creator of Fast.ai. And he's usually tweeting about the latest papers, mostly in the deep learning space, but obviously there's a lot of people that he follows that you can then sort of follow as well, that are tweeting more generally about machine learning. LinkedIn, also, if you follow the right people on your feed, you should definitely get some updates of like what's been going on, some new information. Medium and Towards Data Sciences are two blogs that are really good in providing the latest and greatest. Sometimes it's hard to filter through some of the noise, but in general, you can find really good articles written on there. Let's see, what else? You've got Towards Data Science, Archive, arxiv.org. That's a little bit more for research material, but it still keeps it up to date. What I like about Medium and Towards Data Science and certain bloggers is that they'll take these research papers, implement them, and then write up a much more human readable version of it, because research papers are written for researchers, right? So sometimes the language can be a little difficult to follow, and it'll be a little dense because they have to cram everything within sort of not a page requirement, but they try to write as few pages as possible instead of writing a much longer version of the introduction. Text resources, I think, are really important, especially for those looking to get into data science. My favorite book, and one that I highly recommend everyone just get a copy because it's free online, is Introduction to Statistical Learning with R. So the with R is not important. The book itself is written in such a phenomenally easy to understand way. They've abstracted some of the math away and just really talk about the high level, what it's doing. And then they show you a little bit of the mathematics. But it is a great way to understand how these machine learning algorithms work. And then if you don't know which programming language to choose, you can already just use the code that's provided for you and run it in R. There are some places where if someone has rewritten basically all of the code from R and translated it to Python. So if you're doing Python and want to do Introduction to Statistical Learning, there are websites or blogs out there that have basically taken all of the material from each of the chapters and converted it to Python so that you can follow along and then write and execute that code in Python. So ISL, right? Introduction to Statistical Learning. That's usually what it goes by. That's its short name, ISL. And then my favorite book for learning more about probability and statistics is called An Introduction to Probability. by Sheldon Ross. I can't remember if it's Sheldon, but it's definitely Ross, and I think it is Sheldon Ross. You should be able to find a version online there, and that book really covers an introduction to combinatorics, probability, Bayes theorem, conditional probabilities, central limit theorems, etc. And these are the depending on where you interview, the questions will range from like the first couple of chapters to like the middle of the book, depending on the technical level of expertise depending on where you're going. Like for example, I interviewed at Google, and I know that I had a lot of questions revolving the central limit theorem and how it was going to be used for a specific probability question that they asked me. Those I think are the two biggest or the two best textbook resources I'd recommend. A third, if you had to use one, would probably be Python for Data Analysis by Wes McKinney if you're going to be learning Python. That's a phenomenal book, probably also available online for free, that walks you through how the Pandas library, which is the most common library for data wrangling and data science if you're using Python, available.
Wow, that is a